Section 12.2 is on angles and angle measure. This is the standard position of an angle on the coordinate plane. So here on the XY axis, we have an angle which is marked out in pink. We say the initial side is this ray that is on the positive x-axis. So the one going straight out from the origin, straight out to the right, that's the initial side. Whenever we're doing angles, they almost always start on the positive x-axis. The terminal side is this ray heading off kind of to the northwest here, because that's where the angle would start and follow the purple little ray here, the purple little arc. The angle starts here and goes around and ends out here. If the angle is positive, then the rotation is counterclockwise, as it is here. If the angle is negative, the rotation would be clockwise. It would start down here, again on the positive x-axis, and go around in the clockwise direction. Okay, so the initial side, the positive x-axis, terminal side, where the angle ends. So let's draw each angle with the given measure in standard position. I'm going to do this in pink so it stands out. So I have a 210-degree angle. So I'll be starting on the positive x-axis, so I can go ahead and draw that. That's my initial side. And then I need to go 210 degrees around. So probably the easiest way to do this, so that's not all the way around. 360 is all the way around, but I need 90 and 90 plus something else. So 210 minus 90 is going to give me 120. Okay, so that would be up to the y-axis here. 120 minus 90 gives me 30. So I need to go, I'll do this in purple, I need to go 90 and 90 and another 30 degrees. So something to like there. Draw that out. It doesn't have to be exact, as long as it kind of looks about right. And so what we're saying here is this is a 210-degree angle because I've gone 90, plus another 90 is 180, plus this 30 degrees right here, this angle right here, little angle right in there is 30 degrees. So that gives me a 210-degree angle. Let's do one that's negative 45 degrees. Again, I'll have my initial side on the positive x-axis. And now negative 45 is going to be going in the opposite direction, so it's going to be heading clockwise this way, and 45 degrees is about halfway, so right to about there. So I will draw this right here, and that would be a negative 45-degree angle. So from the initial side on the positive x-axis, in the opposite direction, in the clockwise direction, 45 degrees. So this little angle right here is 45 degrees, and since we're going in the clockwise direction, it's a negative 45-degree angle. And how about a 900-degree angle? Well, because 900 is obviously greater than 360, we're going to be going around a couple times. So let's figure out how many times we have to go around. So 900 minus 360 gives me 540. So that's one time around. Minus another 360 is going to give me 180. So that's another time around, and 180 degrees is halfway around. So I'm actually going to be going 2.5 times around. So actually, I don't know that I can I draw this one here? Yeah, we'll go ahead and draw this. So there's my positive side. And I'm going to start here, and there's 360 degrees. There's another 360 degrees, and there's 180 degrees, and I'll stop right there. So this is actually a 900-degree angle, same as a 180-degree angle. Coterminal angles are two or more angles in standard position, that is starting on the positive x-axis, with the same terminal side. In other words, they're two angles that start at the same position and end at the same position. Coterminal, ending in the same place. So for example, in the diagram here, A 120 degree angle is this one going from the positive x-axis counterclockwise. And a negative 240 degree angle also starts here at the positive x-axis and goes clockwise for 240 degrees. They're coterminal because they both end at the same spot. Also a 480 degree angle, which would be all the way around for 360, plus another 120, okay, would be the same angle. And negative 600, which would be, what, around once, and another 240 would end right there. So that's just adding basically another rotation to the angle. So this example says find an angle with a positive measure and an angle with a negative measure that is coterminal with a given angle. And to be honest, there's a little shortcut for this. Basically, if you take the given angle and you add 360 to it, and that's going to give us 570 degrees. And if you take the given angle and you subtract 360, and that's going to give us a negative 150 degrees. And there's one positive and one negative angle, and they are coterminal with a 210 degree angle. So in other words, if I start at the positive x-axis and go counterclockwise and stop at 210, I get a 210 degree angle. If I go around another 360, I get to 570. If I start at the positive x-axis and I go backwards, or clockwise I should say, 150 degrees, I'll end up at the same place. So those are two angles, one positive, one negative, that are coterminal with a 210 degree angle. The same thing also works with negative angles. So if I have 120 degrees and I add 360 to that, I'm going to get a 240 degree angle. And if I take a negative 120 and subtract 360 from that, I'll get a negative 480 degree angle. So both of those angles, one positive, one negative, are coterminal with a negative 120 degree angle. Radians. A radian is another way to measure an angle. So it's an alternative to using degrees. And if you'll notice on your calculator, you actually do have two modes. You have a radian mode and a degree mode. Don't change it to radians for this section. We're just going to kind of learn what radians are about here. Keep it in degree mode for the previous section. So if you'll notice from this diagram, the length of this arc on the circle is the same as the length of the radius. So a radian is defined as the measure of the angle that intercepts an arc whose length is the same as the radius of the circle. So if I were to take the length of this radius, okay, if I could just like peel that off of there and lay it on the outside of the circle here, okay, the angle that's formed by that arc is the measure of that we've decided is called 1 radian. So here's why it's kind of cool. Since the circumference of a circle is 2 pi r, 2 times pi times the radius, and you should remember that from geometry. If the radius is 1 unit, so substitute 1 in here for r, then the circumference is 2 pi units. That means that all the way around the circle is 2 pi radians. So 2 pi radians is defined as 360 degrees. So the next thing we're going to do is convert degrees to radians and radians to degrees. And basically it involves a pi and a 180. So to go from degrees to radians, if you're given degrees, multiply that by pi over 180, and that's going to give you that angle measure in radians. If you're given radians, multiply it by 180 over pi, and that will give you the angle measure in degrees. Let's do a couple examples with that, and I'll show you how I remember it. It says to convert each degree measure to radians and each radian measure to degrees. So number one, I'm in degrees. I have 30 degrees. I need to turn it into radians. So to be honest, I can never remember if it's 180 over pi or pi over 180. But since I started in degrees, I need to end up in radians, and I know radians always have pi in the answer. So that means I'm going to have a pi on top and a 180 on the bottom, because my numbers will cancel, but the pi isn't going to cancel. I have to have a pi in my answer. So doing a little canceling here, That becomes a 1. That becomes a 6. So a 30-degree angle in radians is pi over 6. Okay, I can do the same thing here with a negative angle. So negative 50 times pi over 180. Do a little canceling. I think I can only cancel my zeros there. Gives me a negative 5 pi over 18. And when we write that, we don't put the pi kind of out at the end. We actually put it in the numerator. Now to convert radians, 3 and 4 here are in radian measure, and I need to convert it to degrees. I've got to get rid of that pi. So I have 5 pi over 3. So that means that what I multiply it by has to have a pi on the bottom so that my pi's will cancel and go away. So that means it's got to be a 180 on top. So simplifying this, my pi's do indeed cancel. That becomes a 60. So my answer is 300 degrees. So an angle that's 5 pi over 3 is 300 degrees. Okay, and the same thing with negative 7 pi over 3. I need to get rid of that pi, so it needs to be on the bottom. 180 on top. My pi's cancel. That becomes a 60. And I have a negative 420 degree angle. Here's a nice little chart from the book that shows equivalent degrees and radians on the unit circle. You don't need to memorize it at this point. However, if you're going on to something higher in math, it would be really helpful to do so. And arc length. We studied this a little bit in geometry, but we're going to look at it a little bit differently now, especially in terms of radian measure. The length of an arc, it's the arc that is intercepted by a central angle. So you may remember that. We'll take a look at the picture here. I'll come back to the definition in a second. So we have a central angle here that's 100 degrees, because this is the center right here. I need to find the length of this arc right here. Okay, so imagine if this were a pizza. How many inches long, or how many feet, or how many millimeters long is that piece of crust? Okay, let's go back and look at the new definition that we have. New way to find it, the length of an arc, S, so the length of the arc, is the product of the radius of the circle, that's R, and the measure of the central angle, theta, in radians. So the length of the arc is the radius times the measure of the angle, but the angle needs to be in radians. So let's go back here and take a look at our example. So I need to find the length of this arc and round it to the nearest tenth. So I have a 100-degree angle, central angle, and my radius is 4 feet. So I need to turn, first thing I need to do is turn that 100 degrees into radians. So I'm going to have pi on top, so 180 on the bottom. So that simplifies to 5 pi over 9. So that's my theta. So theta is 5 pi over 9. My radius of the circle is 4. My formula was the length of the arc is the radius times theta, or 4 times 5 pi over 9. Rounded to the nearest tenth, just plug that into your calculator. 4 times 5 times pi divided by 9, and it gives you that the length of that arc, so in other words, let me go over this again. This length right here, the length of that arc, if the radius is 4 feet and the central angle is 100 degrees, the length of that arc is approximately 7.0 feet long. So it might be useful to memorize this little formula. The length of an arc of a circle is equal to the radius times the measure of the angle in radians.